students, in the last video I have discussed about trigonometric ratios of some standard angles, and in this video I am going to discuss about trigonometric ratios of complementary angles. Suppose ABC is a right angle triangle, right angled at B, so this angle is 90 degree, and suppose this angle is theta. So in this triangle, sine theta, we know sine theta is the ratio of perpendicular and hypotenuse. So in this triangle, this is the base angle. So this is the perpendicular, this is the hypotenuse. This is the perpendicular here, this is the hypotenuse. So it will be BC by AC. If I draw the same triangle, here this is 90, this part is theta I know. So this angle will be 90 minus theta, because sum of three angles will be 180. This is 90, so sum of these two also will be 90. Now since this is theta, this will be 90 minus theta. Now if I consider this one to be the base angle, then this will be the base and this will be the hypotenuse, this will be the perpendicular. In this triangle, if I calculate cos of this angle, angle C, that is 90 minus theta, then I am going to get curly brown here, because in this triangle this is the base angle, so this is base, this is hypotenuse, so it will be BC by AC. So here you can see in the same triangle, if I consider this angle, then here I am getting sine theta equal to BC by AC. Now if I consider this angle, that is its complementary angle, then I am going to get cos of that angle will be BC by AC. So from these two we can write sine of theta equals to cos of 90 minus theta. These relations we have to remember, because we have to use this in the sums of, we have to remember these relations because these are required while doing sums of 8c. Now first relation is sine theta equal to cos of 90 minus theta. Similarly, now this is the first relation. Second relation we can write cos theta equals to sine of 90 minus theta. Exactly in the same way we can prove this also. Then tan theta will be cot, or you can say cotangent 90 minus theta. Next cot theta will be tan 90 minus theta. Next one is sec theta equal to cosec 90 minus theta, and last one is the cosec theta equal to sec of 90 minus theta. These relations we have to remember because this will be needed while doing sums of 8c. So sine theta equal to cos of 90 minus theta. Another way to remember this one is that if I write their full name, one is sine, its complement is complement of sine, so we write cosine. This is cos, this is sine. You write sine of the angle, here you take its complement. Complement will be 90 minus theta. So just see, for sine I am writing its complement, complement of sine. This is sine, this is complement of sine, this is theta, so you have to write its complement, that is 90 minus theta. Now I am going to start sums of 8c. In exercise 8c, first question is evaluate sine of 10 degree divided by cos of 80 degree. Here first question is sine 10 degree by cos of 80 degree, and we have to find its value. Now here out of sine and cos we have to change any one. Here we are changing the numerator, denominator we are not changing. So instead of sine of theta, we are writing cos of 90 minus theta. We know this relation, sine theta is cos of 90 minus theta. Here theta is 10. So instead of sine of 10, we are writing cos of 90 minus 10 divided by cos of 80. Now cos of 90 minus 10, it will be cos of 80 degree divided by cos of 80. Since both are same, so if I cancel I am going to get 1. So the required value is 1. I hope remaining sums of number 1, they are of the same type, you can do it yourself. Let me show first part from question number 2. Here also we have to evaluate sine 37 degree minus cos 53 degree. Here question is sine 37 degree minus cos of 53 degree. Like the previous sum, out of these two, we have to change any one. It's up to you. If you want, you can change the first part or you can change the second part. Here I am changing the first part. Sine of theta, instead of sine theta, I can write cos of 90 minus theta minus cos of 53. Cos of 90 minus 37. Cos of 90 minus 37 is 53. So cos of 53 minus cos of 53. Here cos 53 minus cos 53, so it will be 0. So the required answer is 0. Here in the bracket you write sin theta equal to cos of 90 minus theta, as we have used this relation. As these three are of the same type, I am showing first part from question number 3. Here question is evaluate sin 25 by cos of 65 whole square minus cos 61 by sin of 29 whole square. Here question is sin 25 by cos 65 whole square minus cos 61 by sin of 29 degree whole square. Here out of these two, change any one. Just like question number 1, here I am changing the numerator. So instead of sin 25, we can write cos of 90 minus 25, as formula is sin theta is cos of 90 minus theta. And this cos 65 will remain as it is to the power 2 minus, here cos 61, cos theta is sine of 90 minus theta. So cos 61 will be sine of 90 minus 61 divided by sine of 29. Now cos 90 minus 25 is 65. Cos 65 degree by cos of 65 whole square minus sine 90 minus 61 is 29. So sine 29 by sine 29 whole square. Here cos 65 divided by cos 65, it will give 1. So 1 square, it will be 1 minus sine 29 by sine 29, it will give 1. So here it will be 1 square. 1 square minus 1 square means 1 minus 1. So required answer is 0. As these two are of the same type, so I am not showing this one. These two you try yourself. Let me show first part from question number 4. Here question is evaluate sec 50 degree sine 40 degree plus cos 40 degree into cosec 50 degree. Now in first part of question number 4, it is given sec 50 degree sine 40 degree and here cos 40 degree cosec 50 degree. Now while doing this type of sum, your first aim to make these two angles equal. So instead of sec theta, we can write cosec 90 minus theta. Sine 40 will remain as it is plus out of these two, change any one. This cos theta we are changing. So cos theta can be written as sine of 90 minus theta into cosec 50 degree. Now cosec 90 minus 50 will be 40 degree. Sine of 40 degree plus sine 90 minus 40 is 50, cosec 50 degree. Now you can see these two angles are equal. These two angles are also equal. Now cosec theta is 1 by sine theta into sine of theta. So instead of cosec 40 degree, we are writing 1 by sine 40 into sine 40 plus sine 50 degree can be written as 1 by cosec 50 into cosec 50. This cosec 50 and cosec 50 can be cancelled. Sine 40 and sine 40 also can be cancelled. So from this part it will be 1 plus from this part also it will be 1. 1 plus 1, 2, which is the required answer. Now question number 5. Express each of the following in terms of trigonometric ratios of angles lying between 0 to 45 degree. First question is sine of 58 degree plus cos of 53 degree. In this question we have to express this trigonometric ratio in terms of angles lying between 0 to 45 degree. So we have to change this angle and this angle. First part of question number 5, it is given sine of 58 degree plus cos of 53 degree. And we have to express this expression in terms of angles lying between 0 to 45 degree. So instead of sine theta, we can write cos of 90 minus theta. Here theta is 58, so it will be 90 minus 58 plus cos theta, it will be sine of 90 minus theta. As we have to express this in terms of angle between 0 to 45, so we have to change both. Now cos of 90 minus 58 is 32 plus sine of 90 minus 53 is 37. Now these two angles are below 45 degree, so this is the required expression. In question number 6, it is given express cos 65 degree plus tan 65 degree in terms of angles between 0 degree and 30 degree. So this sum is also quite similar to question number 5. Cos of 65 degree plus tan of 65 degree, and we have to express this trigonometric ratio in terms of angle lying between 0 to 45 degree. And we have to express it in terms of angle lying between 0 and 30 degree. So instead of cos of theta, we can write instead of cos theta, we can write sine 90 minus theta, plus instead of tan theta, we can write cot 90 minus theta. So sine 90 minus 65, it will be 25 degree, plus cot of 90 minus 65, it will be cot of 25 degree. Now as you can see, both the angles are below 30 degree, so this is the required expression. In question number 7, it is given that tan 10 degree, tan 25 degree, tan 45 degree into tan 65 degree into tan 80 degree, and we have to prove that this is equals to 1. Now while doing this type of sum, first of all we have to make groups in such a way that sum of the angles should be 90 degree. Here as you can see, this is 10 degrees and this is 80 degree. 80 plus 10, 90. So these two you keep within bracket. Here tan of 25 and tan of 65, sum of these two angles 90. So these two you can keep within bracket, and tan 45 you can keep it separately. Now out of these two, change any one. Instead of tan 10 degrees, we can write cot 90 minus 10 into tan of 80 degree. Here tan theta is cot of 90 minus theta, so it will be 90 minus 25 into tan 65 into tan 45. We know tan 45 is 1, so here we can write 1. Here it will be cot 90 minus 10 is 80 into tan of 80. Cot of 90 minus 25 is 65 into tan of 65. Cot 80 is 1 by tan 80 into tan of 80. Cot 65 is 1 by tan 65 into tan of 65. These two I can cancel. These two also can be cancelled. So from this part I got 1. From this part also I got 1. And 1 into 1 is 1. Hence proved. In question number 7, second part, it is given. We are to prove that sine 10 degree by cos of 80 degree plus cos 47 degree into cosec 43 degree, and we have to show this is equals to 2. Now here out of these two, change any one. So we are changing the numerator. Instead of sine of 10, you can write cos of 90 minus 10, and denominator we are not changing. It will remain cos of 80, plus out of these two, change any one. So cos of 47 can be written as sine of 90 minus 47 into cosec 43. Our main aim is to make the angles equal. These two angles should be equal. These two angles should be equal. That's why we are not changing both. Any one we have to change. So cos 90 minus 10, it will be cos of 80 by cos of 80, plus sine of 90 minus 47, it will be sine of 43 into cosec 43. Now cos 80 and cos 80, they can be cancelled, and here you are going to get 1. If I cancel cos 80 by cos 80, it will be 1, plus sine 43, it can be written as 1 by cosec 43 into cosec 43. These two again can be cancelled. So from this part 1, from this part 1, 1 plus 1, 2, which is the required right hand side. These two I have shown. I think third part from question number 7, you can do it yourself. Let me show question number 8 now. In question number 8, first and second question, they are just like first part of question number 7. So I am not showing these two. Let me show third part from question number 8, and we are to find the value of this expression. Here question is 4 sine to the power 4 30 degree plus cos to the power 4 60 degree minus 2 by 3 sine square 60 minus cos square 45 plus half tan square 60 degree. So 4 sine 30, we know value is half. So half to the power 4 plus cos 60 half to the power 4 minus 2 by 3 sine 60 value is root 3 by 2 whole square minus cos 45 is 1 by root 2 whole square plus half tan 60 is root 3. Since it is tan square, it will be root 3 square. So 4, 1 to the power 4 is 1, 2 to the power 4 will be 16 plus 1 to the power 4 1, 2 to the power 4 16 minus 2 by 3 root 3 square 3, 2 to the power 2 4, minus 1 square 1, root 2 square 2, plus half root 3 square 3. So 4, 16 will be the LCM. 16 by 16 1, 1 1 ja 1, plus 16 divided by 16 1, 1 1 ja 1, minus 2 by 3. Here LCM will be 4. 4 divided by 4 1, 3 1 ja 3, minus 4 divided by 2 2, 2 1 ja 2, plus 3 1 ja 3, 3 by 2. So in the next step it will be 4 into 1 plus 1, 2 by 16, minus 2 by 3 into 3 minus 2, 1, 1 by 4, plus 3 by 2. 4, 4 ja 16, 2, 2 ja 4, minus 2, 2 ja 4, 1 by 3, 2 ja 6 here, 2, 2 ja 4, so it will be 1 by 2 plus 3 by 2. So from the first part, 1 by 2 minus 1 by 3, 2 ja 6, plus 3 by 2. Here it is 2, 6, 2. If we take the LCM, LCM will be 6. 6 divided by 2, 3, 3 1 ja 3, minus 6 divided by 6, 1, 1 1 ja 1, plus 6 divided by 2, 3, 3 3 ja 9. So 9, 10, 11, 12. 12 minus 1 by 6, that will give 11 by 6, which is the required right hand side. In fourth part of question number 8, it is given, we have to find the value of this expression. Here we can write 2 by 3 cos 30. Cos 30 is root 3 by 2 to the power 4, minus sine 45. Sine 45 is 1 by root 2 to the power 4, minus 3 sine 60 root 3 by 2 square, minus sec 45. Sec 45 is opposite of cos 45, so it will be root 2 square, plus 1 by 4 cot 30. Cot 30 is root 3, so root 3 square. So 2 by 3 root 3 to the power 4, root 3 into root 3 into root 3 into root 3, root 3 into root 3 3, root 3 into root 3 3, so 3 3 ja 9. So from here we will get 9, 2 to the power 4 16, minus 1 to the power 4 1, root 2 to the power 4. Here also it will be root 2 into root 2 into root 2 into root 2. This will be 2, this will be 2. So 2 2 ja 4. So it will be 4, minus 3, root 3 square 3, 2 square 4, minus root 2 square is 2, plus 1 by 4 into 3. So 2 by 3, here LCM will be 16. 16 divided by 16, 1. 1 into 9, 9, minus 16 divided by 4 is 4. 4 1 ja 4, minus 3. Here LCM will be 4. 4 divided by 4, 1. 3 1 ja 3, minus 4 divided by 1, 4. 4 2 ja 8, plus 3 1 ja 3, 3 by 4. So in the next step it will be 2 by 3 into 9 minus 4, 5 by 16, minus 3. 3 minus 8 will be minus 5 by 4, plus 3 by 4. Here 2 and 16 can be cancelled, so we will get 8. So it will be 5 divided by 24, minus minus plus, 3 5 ja 15 by 4, plus 3 by 4. Here LCM will be 24. 24 divided by 24, 1, 5 1 ja 5, plus 24 divided by 4, 6, 15 into 6, 90, plus 24 divided by 4, 6, 3 6 ja 18. Now if you add these 3, it will be 113 by 24. In the mixed fraction, it will be 4, 17 by 24. So which is the required answer. Now in fifth part of question number 8, it is given cosec 65 degree plus theta minus sec 25 minus theta minus tan 55 minus theta plus cot of 35 plus theta. And we have to find the value of this expression. Here cosec theta, this whole thing you consider theta. So cosec theta will be sec 90 minus theta. Clear? Cosec theta will be sec 90 minus theta. This is already in sec, so we are not changing. So this will remain as it is. Here out of these two will change one. This tan theta can be written as cot 90 minus theta plus cot of 35 plus theta. So out of these two, first part I have converted to sec, and here also out of these two, tan is converted to cot. Now sec 90 minus 65. 90 minus 65 is 25, plus minus minus theta, so it will be 25 minus theta, minus sec of 25 minus theta, minus cot 90 minus 55. 90 minus 55 is 35, minus plus theta plus cot of 35 plus theta. So this is positive, this is negative. So their equal and opposite cancels each other. Here also they can be cancelled. So net result is 0. Now in first part of question number 9, it is given evaluate sine 50 by cos 40 minus cosec 40 by sec 50 minus 4 cos of 50 degree into cosec 40 degree. Here, like the previous sums, what we will do? Out of these two we will change any one. Out of these two we will change any one. And here also out of these two we will change any one. Because our main aim is to make these two angles equal, these two angles equal, and these two angles equal. So sine of theta, cos of 90 minus theta, this cos will remain as it is, minus cosec theta is sec of 90 minus theta by sec of 50, minus 4 cos theta is sine 90 minus theta, and this cosec theta will remain as it is. So cos 90 minus 50 is 40 degree by cos of 40, minus sec 90 minus 40 is 50. So sec 50 by sec 50, minus 4 sine 90 minus 50 is 40 degree. So sine of 40 degree into cosec theta is 1 by sine 40. These two I can cancel. These two also can be cancelled. These two also can be cancelled. From this part it will be 1 minus. From this part 1 minus 4. So 1 minus 1 minus 4, it becomes minus 5. 1 minus 5 is minus 4, which is the required answer. I hope number 2 and 3 you can do it yourself. Let me do fourth part of question number 9. We have to find the value of sine 18 degree cos of 72 plus root over 3 plus root 3 tan of 10 degrees, tan of 30 degree, tan 40 degree, tan 50 degree, and tan 80 degree. Here also, like the previous sum, sine of 18 cos of 72. Out of these two, any one we have to change. So instead of sine of 18, we are writing cos of 90 minus 18 by cos of 72 plus root over 3. Here tan 10 degree and tan 80 degree. 80 plus 10, 90. So these two will be grouped together. Here 40 plus 50, 90. So these two will be grouped together, and tan 30 degree will be kept separately. Now cos 90 minus 18 is 72. Cos 72 by cos of 72 plus root over 3. Tan theta is cot of 90 minus theta into tan of 80. Out of these two we have to change any one. So we are changing the first part. Tan 40 will be cot of 90 minus 40 into tan of 50 into tan 30 degree. You know the value, 1 by root 3. So out of these two I have changed 1. Out of these two also we have changed the first part. So cos 72 and 72 can be cancelled. So it will be 1 plus root over 3 cot 90 minus 10 cot of 80 tan theta. Tan theta is 1 by cot theta. That means tan 80 degree will be 1 by cot of 80. Cot 90 minus 40 is 50. So it will be cot of 50. Tan of 50 will be 1 by cot 50 into, here 1 by root 3 can be written separately. This root over 3 and this root over 3 can be cancelled. These two can be cancelled. These two can be cancelled. So from the first part 1, from the second part also 1, 1 plus 1, 2, which is the required answer. In first part of question number 11, we have to prove that sin theta into sine of 90 minus theta minus cos theta into cos of 90 minus theta equals to 0. Sin theta into sine of 90 minus theta, sine of 90 minus theta is cos theta, minus cos theta, again cos of 90 minus theta is sin theta. So we got sin theta into cos theta, minus here also it is sin theta into cos theta. So required answer is 0, which is the required right hand side. In second part of question number 11, it is given tan 90 minus theta into cot theta by cosec square theta minus cos square theta, and we have to prove that this is equals to 0. Now in this case, here tan of 90 minus theta will be cot theta into cot theta divided by cosec square theta minus cos square theta. Now cot into cot square theta by cosec square theta minus cos square theta. Now cot square theta, cot is cos by sine. So instead of cot square theta, we can write cos square theta by sine square theta. Cosec square theta will be 1 by sine square minus cos square. So here cos square by sine square divided by 1 by sine square. This can be written like this, cos square by sine square divided by 1 by sine square. So cos square by sine square, if I write into, it will be sine square by 1, because instead of division we are writing multiplication, so we have to take the reciprocal of it. This sine square and this sine square will be cancelled. So as a result, we are going to get cos square theta. Now from the first part, this sine square and this sine square will cancel. It will be cos square minus cos square, and cos square theta minus cos square theta will be 0, which is the required right hand side. In third part of question number 11, you are to prove cos 90 minus theta sec 90 minus theta into tan theta by cosec 90 minus theta sine of 90 minus theta into cot of 90 minus theta plus tan 90 minus theta by cot theta, and we have to prove that this is equals to 2. Here cos of 90 minus theta is sine theta, sec of 90 minus theta is cosec theta, tan of theta here, cosec 90 minus theta is sec theta, sine of 90 minus theta is cos theta, and cot of 90 minus theta is tan theta, plus tan of 90 minus theta is cot theta by cot theta. This tan theta and this tan theta can be cancelled. This cot and this cot can be cancelled. So it will be sine theta into, instead of cosec we can write 1 by sine. Sec theta can be written as 1 by cos into cos plus 1. This sine and this sine can be cancelled. This cos and this cos can be cancelled. So it will be 1 plus 1 and 1 plus 1 2, which is the required right hand side. Question number 12, we are to find the value of theta where cos of 2 theta equal to sine of 3 theta, where 2 theta and 3 theta are acute angles. Here cos of 2 theta equal to sine of 3 theta. So since this side it is cos and here it is sine, so we have to change either of them. So instead of cos theta we can write sine of 90 minus theta, and here it will remain as it is. Now sine of 90 minus theta equal to sine of 3 theta, that means this angle equal to this angle. We can't cancel this sine and this sine because only sine carries no meaning. Since sine of this angle equal to sine of 3 theta, that means 90 minus 2 theta equals to 3 theta, minus 2 theta minus 3 theta equals to minus 90 degree, minus 5 theta will be minus 90, which will give 5 theta equals to 90, theta equals to 90 by 5, so theta is 18 degree, because 90 divided by 5 is 18, so required value of theta is 18. Now if you see the 12th third part, here also same question. Here it is given sine theta is cos of theta minus 45, and we have to find the value of theta. Here in the left hand side it is given in terms of sine, and here it is cos. So we have to change this sine to cos, then only I can compare. So sine theta can be written as cos of 90 minus theta equals to cos of theta minus 45, cos of theta minus 45. So since cos of this angle equal to cos of theta minus 45, that means 90 minus theta must be equal to theta minus 45. So minus theta, this theta I have transferred, so it will be minus 45 minus 90, minus 2 theta equal to minus 135. So 2 theta equals to 135, theta will be 135 by 2, that means 67.5 degree. This is the required value of theta. I hope question number 12 is clear, and question number 13 is also of the same type. I hope this one you can do it yourself. So I am showing first part of question number 14, and that will be the last term from this exercise. In question number 14 it is given, if ABC are interior angles of triangle ABC, we are to show sine of B plus C by 2 equal to cos of A by 2. As given in the question, ABC are interior angles of a triangle. From the angle sum property we know sum of 3 angles is 180 degree, so it will be A plus B plus C will be 180 degree. Now in the question it is given sine of B plus C by 2. So we are going to keep B plus C in one side and 180 and A in the other side. So in the next line it will be B plus C equals to 180 minus A. Again in the question it is given B plus C by 2. So we can divide both sides by 2. It will be B plus C by 2 equals to 180 degree minus A divided by 2. So it will be B plus C by 2 equals to 180 degree by 2 minus a by 2. This can be written as b plus c by 2 equals to 180 by 2 is 90 degree minus a by 2. Now as given in the question, we want sine of b plus c by 2. So we can take sine on both sides. So in the next step it will be sine of b plus c by 2. It will be sine of 90 minus a by 2. So it will be sine of b plus c by 2 equals to, we know sine of 90 minus theta is cos theta. So it will be cos of a by 2. So we got sine of b plus c by 2 equal to cos of a by 2, which is the required expression. Hence proved. I hope this sum is clear, and this is the last sum from this exercise. And in the next video I am going to start from 8D. Take care, bye bye, and wait for the next part.